We are now moving on to organic chemistry, which is the chemistry of carbon. So, when we're looking at organic chemistry, there's a few things that we want to point out to look for when you're identifying if it's organic or inorganic. Organic chemistry is what all living things are made of, which is why it's so important in nursing. It's made of primarily carbon atoms. It has to have carbon in there in order to be considered organic. So it has one or more carbons. It has a lot of hydrogens. Most of the carbon atoms are surrounded by hydrogens. It can also contain oxygen, sulfur, nitrogen, halogens. When we're looking at halogens, what we're referring to is this group right here with like fluorine and chlorine and bromine. Those are the halogens. So it has carbon, nitrogen, oxygen, sulfur, and the halogens. When we're writing it, the carbon's usually written first. So, for instance, C3H8 or C2H6. Carbon's always written first. So, when we're looking at organic compounds, some of the characteristics might come up of being all covalently bonded. Carbon has an electronegativity of approximately 2.1. It's actually very similar to hydrogen. So when the carbon and the hydrogen bonds come together, it actually forms a nonpolar bond. So the majority of organic compounds are nonpolar. That becomes really, really important when it talks about interactions. For instance, covalent bonds, in order for it to be nonpolar, it has to be covalent. Low melting and boiling points, so it melts and boils at low temperatures. The reason why that is related to the nonpolar, because there's no, remember with water, there was a partially negative and a partially positive. And this positive of this hydrogen will be attracted to the negative of the next one. So you'd have this attraction. Because it's nonpolar, there's no attraction between the molecules. Or there's less attraction, I should say. So because of that, they're not trying to hold together as much, which is making it break apart easier. Which is giving it its low boiling and low melting points. They're flammable, they can catch on fire. Notice they're soluble in nonpolar solvents. That's once again because of the nonpolar compound. They are not soluble in water because water is polar. Therefore, they don't want to interact. So they don't have this negative and positive holding it together. Nonpolar doesn't have that. This is just simply saying that that's a picture of oil being mixed with water and the fact that it doesn't mix, which is why it's sometimes dangerous to drive on the roads right after a big rainstorm, because the oil that was on the ground is now risen up on top of the water, and that's going to make the ground slippery. Whenever you're trying to figure out what it is, think of it in this manner. Gasoline that we put in our engine is organic. So when you're thinking about that, gasoline has a very low melting point. In other words, it's a liquid when you put it into the gas tank. It's flammable. It's going to combust in the engine. Right? Think about something that you know is organic and try to match it up with those characteristics. So when we're looking at organic versus inorganic, notice carbon and hydrogen. The carbon in there and the hydrogen in there is making it organic. There's no carbon in NaCl. So therefore it is not organic. It's inorganic. So propane is used for fuel. and salt is obviously used for taste. Let's think about this comparison. This is a liquid, whereas this is a solid. That's because the propane has a low melting point, and the salt has a high melting point, so it doesn't want to dissolve, or it doesn't want to break down. So this is NaCl on the right, and this is propane on the left. Let's think about some more characteristics. It's liquid, so therefore has a low melting point. Also, it's flammable. If this were to catch on fire, that would be a big problem. Whereas salt, if you try to catch salt on fire, it's not. Some other salt can dissolve in water. Whereas the propane would have a little bit more issue with that. So once again, if you're trying to figure out the difference between, think about two things that you know, and one being organic, one being inorganic. So let's take some comparisons right here. Contains carbon, hydrogen, and sometimes these other compounds, whereas inorganic is mainly metals and nonmetals. So sodium chloride is a metal, sodium's a metal, chlorine's a nonmetal. These are called molecules for organic. These are typically ions, ionic compounds, mostly covalent, whereas these are they can be covalent or ionic. Organic is nonpolar, where most of the inorganic are polar or ionic. Low melting and boiling points, high melting and boiling points. Catch on fire very easily, whereas inorganic does not. So these are typically not soluble in water, whereas inorganic are. So once again, this is sodium chloride, and this is propane. So two different compounds that I'm sure that you're very familiar with. Just try to compare those in your mind as you're reading questions. So let's take a look at this. If something has a high melting point, it's probably going to be inorganic. If it's not soluble in water, that's organic. Notice carbon, 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 that means it's going to be organic. There's no carbon in here, that's Cl, that's not carbon. So that's inorganic. Burns in air, that's going to be organic again. And has covalent bonds, that's going to be organic. It could possibly be both, but it's typically going to be organic. Alright, so when we're looking at the periodic table, this is a review of something you should have had in the last class that you took. So hopefully you remembered it. But if we're looking at the periodic table, we count the tall rows over. 1, 2, 3, 4. Carbon is in the fourth row of the tall rows. That means it has 4 valence electrons, which means it's going to have 4 dots around it. 1, 2, 3, 4. Hydrogen is in the first row, meaning it's going to have 1 valence electron, which means it has 1 dot around it. You're going to try to match up the dots so that carbon forms an octet. We call it an octet because we have 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons for oct. So for carbon we have 4 electrons around it because it's in the fourth row. Hydrogen each has 1 electron. And there's 4 of them. So we write it 4 different times. We can connect the dots to make those bonds. And that's how carbon forms the octet, forming 4 bonds. Now, if we're looking at the shape of the compound, Vesper is referring to the shape. Once again, this should be a review from your last class. So, carbon has, once again, it has 4 lines here. Here's the 4 lines. If we spread it out in 3D, and these hydrogens are going to get as far away from each other as physically possible. That's making an angle of 109.5 to make a tetrahedral. To remember it, tetra, there's 4 atoms coming off of it for tetra. And they're spreading out as far as they can. So in order to spread out as far as it can get to 109.5 degrees difference from each other. So this is the tetrahedral. This is the Vesper shape. This is the ball and stick model. This is the models that you would play with or work with at home or in lab. This is space filling. What it's saying here is that instead of having things spread out like this one is, where there's a gap between them, this theory is saying that this gap is actually filled in with the space of the electrons. The electrons are moving around in there. And this is the expanded structural formula, which you'll be using a lot of. It just shows it in 2 dimensions rather than in 3. Ethane is 2 carbons and 6 hydrogens. We're still going to use the tetrahedral formula, or tetrahedral structure, because there's still 4 bonds coming off of it. As long as there's 4 things coming off of it, it's going to be tetrahedral. So there's 1, 2, 3, 4. There's 1 tetrahedral, and then if we're looking at the second carbon, here's 1, 2, 3, 4. So both sides have a tetrahedral shape, and they're linked together with this carbon-carbon bond. So here it is, 1, 2, 3, 4, and that's making the tetrahedral right there. Whereas if we're looking at this carbon, 1, 2, 3, 4. So we have 2 different tetrahedrals going on at the same time. Once again, this is the ball and stick model, space filling, and this is the one you're going to want to be the most familiar with, and that's the expanded structure. So if we're looking at butane, predict the shape around each of them. Well, because they're each single bonds bonded to 4 different things, this carbon is going to be tetrahedral. Whereas if we're looking at this carbon, it's 1, 2, 3, 4, still 4 single bonds. That's going to be tetrahedral as well. So when they're talking about the shape, they're looking at each and every carbon. So each of these carbons all have a tetrahedral shape because they all have 4 things coming off of it in a single bond. And that is the end of the first section of Chapter 1, Chapter 10, the Introduction to Organic Chemistry.